Hey guys, this is Coach Miller. Welcome back. We're going to jump right into the next concept here in Unit 11, and that is electrolytes and dissociation. Okay, when I use the word dissociate, okay, dissociation, it sounds like a really big word and really complicated. Okay, now just think about it. If you want to dissociate yourself with someone, you simply break away from that person. You stay away from them. Okay, that is a dissociation reaction. Okay, it's when two or more ions break apart. Okay, so we're going to jump right into that, and this entire video is all about identifying electrolytes and then writing the dissociation reactions that will accompany those electrolytes. So first thing you need to be able to do is identify what an electrolyte is. You've probably all heard the word before when we're talking about sports drinks like Gatorade or Powerade or any of those other sports drinks that you may have seen. An electrolyte is simply a substance that dissolves in water that allows that solution to conduct electricity. So it produces power, okay, or produces these ions. A way that we identify an electrolyte is simply this. It's any soluble ionic compound is considered an electrolyte. It has to be soluble and it has to be ionic. Okay? Some highly polar covalent molecules will also become electrolytes, but for the sake of what we're doing with this information, all you need to understand is it's soluble, so it's able to be dissolved in water, and it's ionic. Okay, so these are your questions to simply consider. Is the substance ionic? Remember, how do we know that? Is there a metal involved, bonded to a nonmetal, or does it contain a polyatomic ion? If that is true about the substance, then it's ionic. So we've answered one question. We can move on to the second question, and the second question is this. Is that substance soluble? And we have a chart to help us with this. Okay, this is on the back of your periodic table that you all got at the beginning of the year. We have all of these substances that are listed, and they tell us the ions. Okay, for example, all of the ions here, and it tells us if they're soluble. Okay, it tells us soluble, and then it tells us insoluble. Okay, if a compound contains these substances up here, most of the time they're soluble. However, you do have some exceptions, okay, and they're listed there for you. If a substance contains these ions, then most of the time they're insoluble. You can see that here, but there are some exceptions. So you've got to be able to read this solubility chart and be able to identify if a substance is soluble or insoluble. So let's identify this, and then we can take it one step further and actually write the dissociation reaction. And I'll show you how simple that is here as we work through these together. So our first example, calcium chloride, CaCl2. Okay. First question, is it ionic? Calcium is a metal, chlorine, nonmetal. So we've got a metal bonded to a nonmetal, therefore it is ionic. So we've answered the one question. Now we need to identify if it's soluble or not. So we look on here. Here's my negative ion, chlorine. Remember, calcium chloride, so chlorine is my negative ion. It says that chlorine is soluble unless it's bonded to silver, lead, or mercury. Okay, so silver, lead, and mercury wouldn't be soluble. So I'll go back. Is this bonded to silver, mercury, or lead? No, it's not. It's bonded to calcium. So calcium chloride is soluble in water, and because it's soluble in water, if it were placed in water, okay, it's going to break apart into its positive and negative ion. Okay, what is the positive ion here? It's calcium, the metal. It's a positive 2. Okay, so we're going back to previous units, remembering what our charges are for these particular ions. Chlorine, we know, is always a -1 ion. Okay, But we've always got to have a balanced equation, okay? So calcium chloride is going to break up into one calcium ion, because it's a +2, and it's going to break into 2 chlorine ions. So we've got a +2, a -1, right? So that -1, we need 2 of them to balance the charge out. Okay, so you can simply look at the formula to figure out how many of each ion that you're going to need. So because it is ionic and it is soluble, it will dissociate or break apart. And that is the dissociation reaction. Okay, H2SO4, that is sulfuric acid, H2SO4. It is an acid, okay, and it does contain a polyatomic ion, so we are definitely considering that ionic. We're going to look at sulfate, find sulfate here. There's sulfate. It is soluble unless it's bonded to strontium, barium, lead, or mercury. Well, in sulfuric acid, it doesn't have any of those. It has hydrogen. So we know that sulfuric acid is going to dissolve in water. So in the presence of water, it's going to dissociate. It will dissolve. And it's going to dissolve into 2 hydrogen atoms, or hydrogen ions, and 1 sulfate ion. A sulfate is a -2, and the hydrogen is a +1. So it definitely will dissociate. Sodium hydroxide, NaOH. Okay, Na is a metal, hydroxide is a polyatomic ion, so I know it's ionic. So I just need to look at my list here. Where's hydroxide? Here it is. Hydroxide is insoluble unless it's bonded to calcium, strontium, barium, compounds with ammonium, and the alkali metal cations. So alkali metals. Where are the alkali metals? Remember, from a previous unit, our alkali metals are that the first group on the periodic table. Na, potassium, so sodium, potassium, rubidium, cesium, all of those first group metals. So we go back. What is it bonded to? It's bonded to sodium. Okay, so sodium hydroxide is definitely soluble in water because sodium is a group 1 alkali metal. So in the presence of water, sodium is going to break apart from the hydroxide. So we have 1 sodium ion and 1 hydroxide ion. Now, the strength of that ion, or the strength of the electrolyte, is determined by how many ions you create. So in this particular reaction, for example, calcium and chlorine, I get 1 calcium ion and 2 chlorine ions for a total of 3 ions. Okay, same for sulfuric acid. I get 2 hydrogens and 1 sulfate ion, so a total of 3 ions. Okay, in the bottom one, I only have 1 sodium ion and 1 hydroxide ion, so there I only have 2. So that's going to be a little bit weaker electrolyte. But we know that it's still soluble in water, and it is ionic, so it is an electrolyte. So those are some questions that you're going to have to consider as you move forward, and you may see a quiz or a test with these types of questions. Okay, the last 2 we're going to look at together before I see you guys again in next class. Lithium phosphate. Lithium is definitely a metal. Phosphate is a polyatomic ion. So I know it's ionic. The next question I need to ask is this particular compound soluble in water? So let's go back, look at our list. Where's phosphate? Here's phosphate. There's my negative ion. Phosphate is insoluble unless it's bonded to ammonium or an alkali metal. Okay? Lithium happens to be an alkali metal. So it is ionic, it is soluble. Therefore, we can write a dissociation reaction. So in the presence of water, lithium phosphate is going to break up. It's going to break up into that lithium ion, which is a +1, and it's going to break into that phosphate ion, which is a -3. But notice, +1, -3. They don't balance each other out. So I can go back and refer to my my formula over here and notice that I need 3 lithiums. Those 3 +1s will balance out that -3 charge of the phosphate. So I've got 3 lithiums, 1 phosphate for a total of 4 ions. That's the strongest electrolyte we've created so far. The most ions created there in solution. Okay, last example, barium sulfate B8 So4. We know it's ionic because it contains a metal and a polyatomic ion in sulfate. So now all we need to do is look at the solubility chart. Find sulfate. Here it is. Sulfate is soluble, okay? But there are some exceptions. If sulfate is bonded to strontium, barium, lead, or mercury, it's going to be insoluble. Okay, so I've got to go back. Barium sulfate. Okay, sulfate is normally soluble, but it's bonded to barium, so therefore it is insoluble. So we're going to put no reaction. Okay, because it is not soluble, it is not an electrolyte. Okay, so that's the other example that you can have. That's the other answer that you could have for these type of problems. You can either write the dissociation reaction because it is an electrolyte, or because of the definition. Remember, it has to be ionic and soluble, and if it doesn't meet both of those criteria, it is not an electrolyte and therefore will not undergo a dissociation reaction. So hopefully this helps you guys out. We'll pick up with some more examples when you guys come to class next time, and I will see you then.